I was just designing some teeth for the magnetic motor, where these 4 power points, which I'll zoom out and show you. So this is the magnetic motor. That area I was just looking at there was meshing that to that. It's not necessary for the small power user. What you're doing is you're generating 12 volt power. You'll have 4 alternators, and these wheels adjust in and out, and they make contact with this wheel here, which is the driving wheel. In this CAD design here, what it is, the alternator fits on there, but it's optional, you don't have to have it. It's just a power takeoff point, which is friction drive at this point, or you can make it a gear drive. This particular software program is eMachine Shop. Next down. eMachine Shop, registered V, just type in eMachine Shop and you'll find it. And you can download it, and then once you get this perfected, get a couple of kids on it. I'll have this thing squeaked so you could build your own magnetic motors with laser machinery, which is available in every city. It could be 50 of them per city. They'll cut that for you for probably under $1,000, supplying the 6mm plastic material, clear plastic, or you can do it in stainless steel or some non-magnetic material. But the 4 points where you see the circles there, they're able to go back and forth, back and forth. Now, I'll just get out of here. So these are 1200 by 1200 sheets of acrylic. You don't even have to supply it yourself. You send this as a DXF file, which is done like this. File, export, and you're exporting it as an AutoCAD DXF that a laser machine can read, and you export it to there. So, yeah, do you want to replace it? Yeah, because I've altered it. So the magnetic application is this. It's very memory intensive. You have to wait to see how the wheel spins like that little thing spinning around there. But this bit is stationary. Right. It's stationary. And what you got is that one, let's say that's a north, a north, a north, a north, a north, south, 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 and they're all norths. So the South Pole is drawn in and around till it gets to here, where it starts to be taken over by a repulsion pole and repels it out in that direction. I'll show you why. Right. We've got these series of magnets in the middle here. And because they're little round every day, buy in the local hardware store and probably in the supermarket. They're 3 mils deep by 20 mil. This is 222 across here. I'll type it in. Right, 222. So this here fits in it. I know. Now this is what controls the speed. So up this pointer here, hit on the pointer, and any red line, click it. And what will happen is this will have a bracket or something on it, maybe a motor drive, probably a motor drive of someone. And it'll cause it to turn like that. Now these on the right have magnets in them. I'll just draw some little magnets. Oh, that'll do. Right, and those magnets run along and are repelled by the North Pole here. So these are North Poles and they're repelled away. They're repelled away. As they're being repelled away, they're setting up inertia. And between them, because they're moving quite quickly, and they are of the same polarity, because they're a flat coin type, like a $2 coin in Australia, which I didn't mean, I was going to do some of those too. There's North Pole on this side facing you, and the other side, which you can't see, is the South Pole. So you can turn them over any way you want and have any configuration, because the magnetic fields are both north repelling north and south repelling south. If you was to turn that over, they would immediately come crashing together. You don't want that. So you're using the repulsion. So we have these been forced together by centrifugal force, repulsion from the centre, and they're trying to come together. As it does, because this one's getting flung away faster, this one then pushes that one. And this one hits the very point of the end of the circle, completely pressurized, and then it starts pushing back and it's going back the other way. By the time it reaches here, it's fully engaged. So these are now, from that point onwards, past dead centre, it's heavy, heavier, 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 heaviest. But this is now being drawn by a series of button magnets around here, which will pull it in and then repel it away. And I'll do the same down here. So I set a course there, another course there. Now, how you do that is really quite easy. You want the pointer, and you go in and select it, and you copy it. You bring up the central bit to go to there, and then you're going to move it to wherever you want it. You can either push it around or you hit the reverse right. And you end up with that'll be in the perfect position for where you want it. That's too far, but it might work. You can look at that. So in a more advanced model, all these would be sliding, actuated So you bring that back. So the optimum is probably there. So you've gone from 1. So what you've done, these things here are now being repelled back towards the centre. So you take one of these, this is actually a magnet, copy it. So the magnet has been coming around at the extremity of the spin at the lowest possible point to then encounter same polarity of the pole, let us say it's North Pole, and start to be driven back up into here. Now, by driving it back up to here is also de-accelerating it, the ball itself, which is a freebie. Doesn't cost anything because it's being drawn in by the magnets that it's just passed. Now these have become such a huge amount. I'll just go over and show you that. Do it again. So let us assume you're down here. This is being pulled in because this is a magnetic field here. So it's pulling it up. And by the time it gets to that position, she's up there tight. And that remains tight up until here, when that magnet there is now North Pole. These are South Poles. That's North. So it's pulled it in. Now these are North Poles. So it's going to blurt that straight out up this direction. Going to push it up like that. And it will then be pressurizing these other ones in front of it, because they'll be all bouncing straight up off each other, and they'll be trying to find an equilibrium. And in doing that, they're imparting energy on the spin. So we're now up into the top position again from, that's the top there, 1, 2, 3, 4, 5, 6 positions down from 90 degrees, right? Because that's where it is, straight up there. All this is freebie. All that is free, because that's in the central part. And suddenly we've hit, that's a North Pole. We hit North Pole there, North Pole there, north, 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 and there is south down below it. Show you again. Keep on forgetting you can't see it. Alright, now, this thing's come around, and from this position here, it's starting to get a north and a north. Right? So what you got is south, south, pulling it up to that position, hits the north. This area then becomes a north, and that pushes the series up. Now, remember there's 3, 4, I had intended to put 8 in here. Right? And that'd be a tremendous push. Now, if they weren't contained in a relatively tight seal, which compresses the air before them, as this would be coming around here, it's building up air pressure. And it's also got repulsion of the magnetic. They'll never come together. Never. If you were to keep on accelerating, and it would keep on pushing these together, it'd be a perfect kiss of speed. Wouldn't go any faster than that. So this one here, it's already on its way. If it's gone up here, it's already overbalanced. This is top dead center. This is overbalanced. So it's sitting up there. So the other one, and there's followed by the 8 behind it, as I said we're going to have, which takes up that much room. Now what I'm doing is I'm getting this cut in. So now we'll have 8 there, another 8 there, another 8 there, another 8 there, another 8 there. Now the reason you have it in 8, well, for divisionable reasons, hard to divide by 3. With a magnet, so we've got a magnet here. Normally you have north fading through to 0, back out to south. With these little magnets, little flat magnets, coin magnets, it's north to side and south to the other. So you can put north, south, north, south, north, south, north, south. So you end up having north, south all the way through, and that becomes south this end and north that end. But on the other side, this is not a North Pole magnet, it's just a series of imitators combining their fields to give you what appears to be a bar magnet, but it isn't. So you'd have north on this side, south on the other side. And in a bar magnet, you've got north this end and south that end. This end, south this side, north the other side. This end, north this side, south the other side. But then you could break them apart. You could take one out. You'd have north, south, north, south, north. Right? Then you have south. No, take that out. North, south, north, south, north. So this is the combinations you can do with this kind of arrangement here with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 magnets. And 8 inside here. Down here we have the same, keeping that in mind. These are all north, 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 north. Or you can call those last 3 or 4 souths if you want. Change and turn them over. Makes no difference. And this is in a mild steel plate. Now the mild steel plate has to be bolted together between other plates, so it'll end up as being 6 mil. So you'll have 6 mil for there, 2 plates, an outer plate which will be 3 mil, and another plate which will be 3 mil. So that's 12 mil thickness of, and you've made a bar magnet with very interesting and unique characteristics. If you wanted to, you can make that plastic, and this is what we're going to do. Everything can be seen what's happening. We don't want to have something that's not transparent. So although it's better to have that as a steel plate on either side, we won't do that. We'll just do a clear plastic so you can see what's happening inside. And they'll be marked accordingly, whether red and blue ink or something. Now these will be, move out a bit, the arrangement for that becomes a pivot point. Sometimes they double up. So if you take one of those little, so I'll go and get one and bring it over. Find it. So we're going to select that. We copy it, paste it, zoom out. I'm going to bring it over to see where this is rotating around here. So these plans will be available once we get it ready to anyone, anywhere in the world for nothing. If you got it, you use it. And, all right, now all right, it pasted itself, which is what I didn't want. It doesn't matter. And we paste again. drag it over. This time get it up close. Now every time with the CAD program, every time you zoom in and zoom out, everything on the page has got to be recalculated. So you've got a very fast computer to keep up with it. Now, up the top here, we can lock that all together. So, and this one here, we do the same thing. Select it. And we go up to the top and we lock it all together. Now, we can put one on top of the other. So that's going to be how it's going to be on the machine. So, take that. We bring it's calculating everything we've done on the page. Thousands upon thousands of calculations. Okay. We're going to zoom in. And that is the pivot point. Right. Now we double click it, move that there, and now we can turn it around. So what you see is, if it feels like it, that'll move up to there, that'll move up, so forth. There's a little bit of line. Right, maybe. Because all I've done is taken this to other pages, designed it up so I can move quickly, and then bring it back over and build one big program for the CAD to send to a laser company to cut it all up out of the specified material. Now, if you are using the same e-machine shop in America, for example, once they get one or two done, and you all get together and come up with the perfect design, then they'll knock them out for next to nothing. They'll just dedicate a machine to run on them 24 hours a day. Or we just give them permission to make them and sell them as a kit. Like, who gives a fuck, as long as it gets out there. This is a weapon of mass destruction. So that's the idea. Now what happens is, you see that this point here to that point there is now becoming raised. So that means these here will lift out of position and back and forth, back and forth, back and forth. So, reopen. You don't want to save it unless you have a reason for it. Not happy. And there it is in the approximation of what will happen as the wheel turns. These will be repelled upwards to here. These are attracting in to repel, attracting in to repel, 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 pulling in, the North Pole, South Pole. And you see the magnets are setting here as a north and north and north, and then it goes south, 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 south. Zoom in and have a look. So you got north, 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 south, 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 south. So it's not a bar magnet, is it? But the fields are going out towards you and back down to here and pushing. And on the other side, it's going the other direction. The south pole is coming around and pushing the other side of this, which is the south pole. So this should make out of a acrylic material, or if you want to do it another way, you make these plates that go over these, and all this out of this mild steel. Or get both. These here, all north poles. These are south poles, pulling it in. Gets to about there, then I turn to north, repel. So it pulls in, repel. So basically you made a bar magnet, flattened it out, chop the magnetic fields up into north and south, away from you or towards you, and make yourself a bar magnet. And then it'll just bend and turn and do what you want to do. You can do a bar magnet in there itself. So it's all joined together like that. You can do that with every third one. You can put coils of wire above these, at these, as passing through it, it'll create electricity. This is stationary and it's fixed probably to some sort of a, something you'd make up, maybe a handle. And by rotating that, we'll stop it. Beneath it, down here, you can install flat magnets like that, which I've got a couple of, and they are a north and south pole. So you can create an artificial gravity by placing it near the machine. Who knows where it all went? Anyway, in front of it, beside it, there are two flat magnets either side of it. Whatever is convenient. You can create an artificial gravity because this is also a gravity wheel. This will work without this being magnetised at all. Throw it all away. Just put steel balls in there. Do the same thing. And it will run. Now, if you just want to use steel balls, you can create an artificial gravity down here. And I'll come ripping down. See what I'm saying? So these can be, if you can't afford the magnets, you get steel slugs. Make sure they're perfect, that's all. And a ferrous magnet like that, but an M42, M50, M whatever now they come out with, in these little beads here, which you can then, when you look on the side, you've got a north-south, right? So you just copy that and paste it. And you've got another north-south. So if you put those two together, the left hand's the south and the right hand's the north. Put that down there. The left hand's the south and the right hand's the north. And they'll fling away from each other. That is why when you put something like that in there, it's going to want to get away from that as best it can. So you work out a way of putting it in. Steel, a little bit of steel. Stick to it, all right, one side, and bolt her up with your plate. Bring your plates from either side. There's all sorts of things you'll learn as you're going along. This is out of the centre of another part of the drawing of one of the front covers. And out of that I wanted to make the bearings up. So we're going to see through this. I've got a 25mm shaft coming along. So you'll have the shaft, then you'll have the bearings mounted all around it, and this thing will have lights running through it, and a very fine line going out around a pulley back down around to there again, and if it don't work, we're going to put a little electric motor on there and make it turn over and just bullshit it works, right? So that's what we're going to do.